Hi everyone, welcome to this week's lesson for Junior Cycle Higher Level. This week's lesson is going to be on cyclic quadrilaterals, trigonometry theory and trigonometry examples, which will incorporate some practical examples. So we're going to go through some theory and then we're going to do some exam questions after that. So the first thing we're going to look at there is what a cyclic quadrilateral actually is. So given a quadrilateral ABCD is shown below. So a quadrilateral is a shape that has four sides. So we have the quadrilateral there, ABCD, is shown below. We can draw through a circle through three of its vertices. So three of its vertices being B, A and D, which I have put a cross through or put an X through. Now a cyclic quadrilateral is one in which all four vertices lie on the circle. So all four vertices must lie on the circle. So you'll see here that that's an example of a cyclic quadrilateral because you have the point A, you have the point B, you have the point C, and you have the point D, and they all lie on the circle. All four vertices, which are the points on the cyclic on the quadrilateral, they all lie on the circle. So all four vertices lie on the circle. Now we're going to have a look at the fundamental theorem of circles to show a basic proof. So if we look at the angle DOB, so it's highlighted in blue there, the angle DOB. You can see it's here, it's highlighted in blue. Okay, so the angle DOB is equal to 2 times the angle DAB, which is this angle here. So what they're saying is that the angle DOB is equal to 2 times the angle DAB. Now, similarly, if we look at the other angles, we use a different colour here, which they have done on the circle there. So the angle BOD, which is this side here, the angle BOD is equal to 2 times the angle BCD, which is this angle here. So 2 times the angle BCD. Now, from that, if we add the two equations, so if we add both of these and let that equal the sum of these two, we get, so the angle DOB plus the angle BOD is equal to 2 times, so the angle DAB that's a D, sorry, plus the angle DCB. Now, we know that that makes up a circle. So this full, I'm going to use a highlighter here again. So this full thing makes up a circle. So that's these two added together. So that's 360 degrees. So 360 degrees is equal to 2 times the angle DAB plus the angle DCB. And because of that, if we wanted to get rid of the 2 here, so 2 is multiplied by this. So if we divide over on this side, so 360 divided by 2 is equal to the angle DAB plus the angle DCB. So then what we get is 180 degrees is equal to the angle DAB plus the angle DCB. And because of that proof there, we conclude with this theorem: opposite angles in a cyclic quadrilateral sum up to 180 degrees. So opposite angles in a cyclic quadrilateral add up to or sum up to 180 degrees. The converse of that theorem is if the angle DAB plus the angle DCB is 180 degrees, then ABCD is a cyclic quadrilateral. So it's the converse of the theorem there. Okay. So we're going to move on to some trigonometry background now. So trigonometry is a part of geometry that concerns solving triangles. So finding lengths of all sides and then measures of all angles. For example, we might know 2 angles on one side, which is in green, and be asked to find the other angles that are in red. So you can see there on the diagram. The following diagram shows the labeling convention for triangles with capital letters for the angles and lowercase letters for the lengths of the sides opposite these angles. Okay, this is really important. So this angle here, this angle A, we always use a capital letter to denote the angle. So the angle A is opposite the side A. So we use a small letter to denote the side and then the uppercase letter for the angle. Similarly, this is the angle B, so we use a capital B and it's opposite the side B, small b. Similarly, this is angle C and this is opposite the side C and we use lowercase. So that's just the notation that we use. Pythagoras' theorem. So in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. So what that means is C squared, which is the hypotenuse, is equal to A squared plus B squared. So that's stating, or that's showing the proof, sorry, not the proof, that's showing the Pythagoras' theorem. So C squared, which is the hypotenuse squared, is equal to the adjacent squared plus the opposite squared. And always the hypotenuse is opposite the right angle. Okay, we're going to look at sine, cos and tan next. So given an angle A in a right angle triangle, we call the sides the hypotenuse, the adjacent and the opposite as follows. So we're just going to explain this. So obviously this is the right angle, and we said just there that the hypotenuse is always opposite the right angle. So there's your hypotenuse. Now if we look at where the angle actually is on that triangle, so we see where angle A is. What side is opposite angle A? Well, it's this side here, and for that reason we call it opposite. So the only side left is the adjacent, and adjacent means beside. So this side here is adjacent to A. So if we were to draw that again, this is your right angle, this is your angle. So always the hypotenuse goes opposite the right angle. So this is your hypotenuse. The side opposite the angle, so the angle is A, so the side opposite angle A is here, and then the other side is the adjacent, which is beside angle A. Okay, we've actually looked at that one already. So now the trigonometric ratios of these angles are defined as follows. If you want to get the sine of A, it's the opposite over the hypotenuse. If you want to get the cosine of A, it's the adjacent of the hypotenuse, and the tan of A is the opposite over the adjacent. Now there's a couple of different ways, different mnemonics and different rhymes you can use to learn these. The one that I usually use is silly old Harry. So silly old Harry, so SOH, so sine equals opposite over hypotenuse. So that's what that is. Caught a herring is the next one. So caught a herring. So CAH, which means cosine is equal to A, so adjacent over hypotenuse. And then finally tan, so trawling off America. So again, you're looking for the first letter there, so TOA. So tan is equal to O over A, so trawling off America. So we look at this example here. Suppose that A is 45 degrees. Solve the following triangle by finding the measure of all of its angles and sides. Okay. We know that this is going to be 90 degrees because the symbol is there for 90 degrees. Now, there are 180 degrees in a triangle, so 180 degrees in total, minus the two angles that we have, so it's 90 plus 45. That's 135, so 180 degrees minus 135 degrees, and that will give us 45 degrees. So that angle there is 45 degrees. So that's the first bit done. So there are two equal angles. We've just seen there that one of the angles is 45 degrees and the other angle is also 45 degrees. So because we're told that, or because we found that out, we now know that it's an isosceles triangle. So that must mean that this side is also equal to this side. So I'm just going to scroll down here. So since there are two equal angles, this is an isosceles triangle, so therefore the corresponding sides are equal. Now we already know that this side is 1, so that must mean that this side is 1 as well. Okay, so we just need to find out what this side is, so x. Now remember Pythagoras' theorem, so I'm just going to put it into this diagram here. So Pythagoras' theorem states that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. The hypotenuse is this one here, so I'm going to call that x. So x squared is equal to the opposite squared plus the adjacent squared. So x squared is equal to, we have the other two sides, so it's going to be 1 squared plus 1 squared. So x squared is equal to 1 plus 1. So x squared is equal to 2. So if x squared is equal to 2, we get x by getting the root of 2. Now we're just going to scroll down here. Yeah, so we now know that the angles and side lengths, we can label them as follows. The hypotenuse, we got root 2 there. And everything is labelled there. Now, just the sine, cos, and tan. These are given to you in your log tables, so you don't have to learn them off. But you could easily get them yourself by looking at the diagram. Like sine is opposite over hypotenuse. Now, the hypotenuse is 1. Sorry, the opposite is 1 and the hypotenuse is root 2. So that's 1 over root 2. And that's where we're getting this from. So the sine of 45, sorry, should I say. Okay, so the cos of 45 degrees. So cos is A over H. A, in this case, adjacent is 1 over root 2 as well, because that's the hypotenuse. And then finally, tan of 45 is O over A. So what's the opposite in this case? The opposite is 1, and the adjacent is also 1. So 1 over 1, which is 1. Now, you can use sine, cos, and tan buttons on the scientific calculator, and you need to make sure, just going to underline this, make sure that your calculator is set for degree mode on that. So you can get the sine, cos, and tan of different angles by literally just typing it into the calculator. Okay, so this is kind of going back over trigonometric ratios. We've gone through that already, so sine, cos, and tan and what they actually mean. And I've given you the mnemonic or rhyme to help remember that as well. So, okay, we're going to move on to solving right-angled triangles. So the first question there, find the measure of the unknown angle and the lengths of the unknown sides in the following triangle. Okay, well, we know that this is going to be 90 degrees because that symbol there means that it's 90 degrees. So we know that we'll call this x, and we know that x plus 90 plus x plus 90 plus 35 all add to 180. So we'll write that out in an equation. So 90 plus 35 plus x gives us 180 degrees. So x is equal to 180, take away 35, take away 90. So x is equal to 55 degrees. Okay, so x is 55 degrees. They've labelled it B there, so B or x, that missing angle is 55. So they're also asking us to get the length of the unknown sides in the following triangle. So if we use, I'll scroll down actually here. So if we look, they've labelled it side A. So if we're looking for side A, we're going to write into the triangle what we know. So this is the hypotenuse. And I'm going to look at this angle. So I'm going to use this as my angle. So if 35 degrees is my angle, this must be my opposite. And this must be my adjacent. So we want to get what the opposite is. So we need to use what we have and what we're looking for. So we're looking for the opposite. So we need a formula that has the opposite in it. And the only other side that we know is 6, which is the hypotenuse. So O and H is the one that we need to use. So it's going to be the sine. So the sine of 35 is equal to O over H. So the sine of 35, in this case, so O is, we'll call it the letter A over hypotenuse, which is 6. So then what we're going to do is going to isolate A on its own. So we're bringing 6 over here. So it's 6 sine 35 is equal to A. And you put that straight into the calculator. And we'll just scroll down. So they've actually used a decimal. Now you can literally just type in 6 sine 35. So A is 3.442. Now if we were asked to get it correct to one decimal place, we'll say it would be 3.4. So that's for A. Now, if we were to look for B, so I'm going to do this in a different color, I'll do it over here. So if we were looking for B, we now have what the other side is, we're after getting 3.442. And we're looking for B, so the adjacent. So we're looking for a formula that has adjacent in it. And I would go and use the hypotenuse because that's what we're given, just in case you made a mistake in the previous question. So we need a formula with A and H. So that's going to be cosine. So the cos of 35 degrees is equal to A over H. So in this case, it's cos of 35 degrees. So A in this case is B. So this letter B, so the adjacent is B, over the hypotenuse, which is 6. Okay, so we want to bring the 6 over here. So it's going to be 6 cos 35 is equal to B, which will give us our other side. And that is going to be, so 4.2 4.915. So 4.915. So B is equal to 4.915. And that's the answer to that one. Okay. Another example. What is the length of the hypotenuse in the following triangle? Okay, so the hypotenuse is obviously going to be this side because, so we'll call that HYP for the hypotenuse, because this is 90 degrees. So they're asking us for the length of the hypotenuse. So let's label our sides. So we have our hypotenuse labelled. This is our angle 50, so this must be the opposite because this is the side that's opposite 50. And 2 is our adjacent. Now we have to use what we have. So we have 2, so we need to use a formula with adjacent in it. And we are looking for hypotenuse. So we need a formula with A and H. And that's going to be cos. So the cos of the angle, so cos of 50 is A over H. So cos of 50, so fill in what we have. So the adjacent is 2 over the hypotenuse. So that's what we're looking for. Now here, we have to do a bit of a switch. So we want to get the hypotenuse on its own. So I'm going to bring the hypotenuse over here first. So it's going to be cos of 50 by the hypotenuse is equal to 2. And now I want to get the hypotenuse on its own. So the hypotenuse is going to be 2 divided by cos 50. So you can put that straight into the calculator and you get 3.111. So the hypotenuse is 3.111. And they've left it to 3 decimal places. Usually it'll ask you for 1 or 2, but in this case we've left it at 3. So this brings us to the papers. So the first one I have here is 2014 and it's question 10. Okay, so this is an overlap of triangles. So question 10, A, B, C and D are 4 points on the circle as shown. AD bisects the angle BAC. P is the point of intersection of AD and BC. Now it's asking us to show that the triangle ADB, so ADB, which is this triangle here, I'm just going to outline it, ADB, I'll use a different colour. So they're asking us to outline or show that the triangle ADB and APC, so APC, they're similar. So you want to show that the triangle ADB and APC are similar. Now the way we're going to do this is by showing that the two triangles have the same angles. Now we're told in the question that AD bisects BAC. So AD bisects BAC. So AD, again I'm going with a different colour again, is straight down the middle there. So AD bisects BAC. So because of that, this angle equals this angle. Now you need to use proper notation. So we'll write down, so AD bisects BAC. Okay, so because of this, the angle BAD, which I've outlined there in the diagram, so the angle BAD is equal to the angle PAC. Now also this angle here and this angle here, they lie on the same arc from A to B. So because of that, they must be the same as well. So we'll just write that out properly. So the angle ADB, so the angle ADB and the angle ACP lie on the same arc from A to B. So they must be the same. So because of that, the angle ADB equals the angle ACP. So both of those should cover you there for showing that the triangle ADB and APC are similar. Okay, I'm going to scroll down here. Show that the length of AC multiplied by the length of BD is equal to the length of AD multiplied by the length of PC. Now, since the two triangles are similar, which we've just proved, corresponding sides must be in proportion to one another. So because of that, the side AC over the side AD would be the same ratio as the side PC over BD. Now, if we cross multiply those, we get AC multiplied by BD is equal to AD multiplied by PC, which is what we were asked to prove there. So that's that question done. Okay, so we're going to go on to 2018 paper 2. So this is a trigonometry question, and this is question 10. Okay, so Grace is putting some stairs into a new house. The diagram on the right shows the three of the steps in the stairs. Each step consists of a riser and a tread. So you can see it on the diagram there. So a riser and a tread. All of the risers in the stairs are the same size as each other. Okay, all of the risers in the stairs are the same size as each other, and the treads also are the same size as each other. So all of the risers, so there's another riser and there's another riser. That's the same as this riser here. And then the treads, so this is another tread and this is another tread. So they are the same value as this tread here. Okay, the table below shows the measurements for stairs in a private and public building. The optimum length is the best possible length. Okay, so we have the table there of measurements. Grace's stairs will have the optimum size step for a private building. Okay, so optimum size step for a private building. Grace's stairs will climb a total vertical height of 2.1 meters. So the sum of the risers is 2.1 meters. So you're going to be going up in total 2.1 meters. Work out the horizontal length of Grace's stairs, so the sum of the treads. Okay, so the sum of the treads. Okay, we have been told that Grace she needs an optimum size step for a private building. So that means that we're going to be looking at the private measurements, which are these ones here. Okay, so that's the ones that we're focused on. Now, you'll also notice that this is given in millimeters, and what we were given there is the sum of the risers was 2.1 meters. So we need to convert them all to the same unit. So there's 1,000 millimeters in a meter, so 2.1 meters is 2,100 millimeters. Now, if Grace's stairs have the optimum size step, that means that the risers are going to be 175 millimeters. So we want to see how many of those are in the total height, which is 2,100 millimeters. So we divide it by 175 millimeters and see what we get. So put that straight into the calculator. When you put that into the calculator, you get 12 risers. Now, if there's 12 risers, that must mean that there's also going to be 12 treads. Now, the optimum tread for a private building is 250. So we need to multiply that by 12. So 12 multiplied by 250 to see the total. That gives you a total of 3,000 millimeters. Now we could convert that back to meters, so 3,000 divided by 1,000 is going to be 3 meters. And that is the sum of the treads, which is what you were asked for. Okay, so we're going to go to the next part now. The angle of elevation of Grace's stairs is marked A on the diagram on the right. Using trigonometry and without measuring, work out the size of angle A and give your answer correct to the nearest degree. Okay, so I'm going to redraw the triangle here. And we're looking for the size of angle A. Okay, so A is here. Now we're just after working out that the treads was 3 meters and the risers we had from before was 2.1 meters. So if we label that right, that is a right angle triangle, there's your right angle. So this is your hypotenuse. This is the angle here, which means this is the opposite, and this is the adjacent. So we're looking for angle A. So we need the A is the unknown, which means we need to use what we have. So we have the opposite and we have the adjacent. So O and A. So we need a formula that has O and A in it. So that's going to be tan. So the tan of A is equal to the opposite over the adjacent. So the tan of A is equal to the opposite, in this case is 2.1, divided by the adjacent, which is 3. Now, we want what A is, not what the tan of A is. So we need to get rid of the tan. We need to bring it under the equal sign. Now, there's a rule here. When you bring tan under an equal sign, we get the tan inverse. So we get A is equal to the tan minus 1 of 2.1 over 3. Now, in order to get tan minus 1 on your calculator, so I'm just going to make a note up here. So you press the shift button or the shift key, and then you press tan, and it'll give you the tan minus 1. So to get tan minus 1. So you press the shift key on your calculator, then press tan, it'll convert to tan minus 1. Now when you put that into the calculator, so the tan minus 1 of 2.1 over 3, you're going to get a really long number. You're going to get 34.9920202. Now you were asked to give your answer correct to the nearest degree, which means that you need to round all of this. But you're looking at this number here, so the 9. Now you're going to round that up. So 34.9920202 is rounded to 35 degrees. So that's a mix of trigonometry and cyclic quadrilaterals. So I'm going to attach some extra links and video tutorials, to the chat. I'd recommend that you follow them because there's extra material there on the website that you can use. And that's it for this week, and I will speak to you next week.